Good morning, everyone. So I think all are back settled up after the tea. So today I want to make this presentation more interactive. So I'm going to ask you some questions. Maybe you'll be more interacting with me during the session. And I won't bore you with a lot of technical details. So I'm going to cover you. So my major agenda of this talk is to let you understand what is platform engineering and what are the lessons I have learned in the journey and what is the good ways that you can build a platform and what are the the things that you need to avoid while building the platforms and doing the platform engineering. So before I am going to start on the presentation, let me just introduce myself. I am Bhavani Indukuri, so working as a senior platform engineer at DigitalOcean, and I'm an international speaker. Along with it, recently I did a co-chair for Cubicon India, and so this Postgres Women India community is very well resonates with me because I do the same with the Cloud Native Computing Foundation. Try to inspire more women, try to bring more women to the table and try to help women to get into the leadership roles and try to let them speak and let them shine in the journey. And I'm a CNCF ambassador. CNCF is a cloud native computing foundation and it's open source. It has all the open source projects under cloud native umbrella. And finally, I'm very much into Kubernetes world. So my work currently is also revolved everything around Kubernetes. So I'm a certified Kubernetes administrator. This is all about me. So now let's talk about platform engineering. So how many of you are students here? And how many of you heard of DevOps? So you might have told like DevOps is very good and you can, right? You can join and get started. How many of you heard of those words? DevOps is booming and you can just learn DevOps and join, right? How many, sorry, how many of you know site reliability engineering, SRE? How many of you heard of it? Very less, and students are very much familiar with DevOps, right? How many of you heard about platform engineering? Very less. This is good sign for my talk. So, so before we actually talk about platform engineering, so let me start through how we have started this journey. So, I have around 10 years of experience. My initial days were like to deploy a product, to deploy a feature. You need to set up the instances by yourself. So you need to go to the IT teams and ask them, hey, I need to deploy this application. So can I get a machine? And then once you get a machine, you will actually run the at the time you have chef and all of that, so install like whatever the things are needed to ship your product. And actually there are a lot of manual steps needed, and that's where I used to work very late nights to actually I used to deploy Android and mobile application onto the stores. Everything is a lot of manual that days, and to scale that also you need a lot of manual efforts required, which is not at all scalable. From then, we were slowly, got to know about this DevOps, right? So initially it was build and release engineering, then it transformed to DevOps, where so the point of containers, containerization. So from virtual machines to containers, where everything gets isolated from your operating system and your application is a small entity that can run inside a container. So then things got become very easy, and we go from a monolithic application to microservices. We deploy a lot of things through containers, and that's when the DevOps comes into picture, where DevOps doesn't only mean that you are going to use containers like that. It also means you're bringing up a process how you deliver your software, how you build your software once the developers develops the software, how you deliver it to production by automating the processes of releases and process of delivery and process of deployment. That's when the DevOps comes into picture. And still people, that people have this buzzword of DevOps at every place. Now, the problem with the DevOps, I will tell you. So, for example, in a company, so you have developed a feature, and you are a developer, and you want to deploy to the production, right? So, how do? You will. So there are some DevOps team where you will be. If you want anything, you need to create a ticket. Like, so I need a pipeline to build my software. Like, can you see, for example, you're initially starting of building your feature or your product, you have to create a repository and you need to build a pipeline to make that having integrated with the tests and getting deployed to the Artifactory or the place where you deploy, and then finally deploy to your production environments. That deployment production through different toolings, like it depends on what tools your organization uses, whether it's Argo CD or any other things, right? So this all, like, you need to actually manually talk to people or create tickets that, hey, so I have this feature, I need to deploy, can you create a repository, can you make a pipeline, can you give us a test results, or like finally deploy it. So this is where the problem with the DevOps lies in. And the point that I wanted to make on the SREs, so site reliability engineering is slightly different. Site reliability engineering means for your production system, how you are making your system more reliable that customers can trust. That is site reliability engineering. So, for example, you could actually see there are a lot of breakdowns these days, like with the Cloudflare. So the system is down, whole internet is down. So whatever the applications that are using Cloudflare, those went down because there is a one thing. That is actually the reliability, we call it as. Because if a system is down means there is a lot of, so even now a lot of people talk about there are 2 times Cloudflare incident happened. So that's the problem that site reliability engineers tries to talk. So that's where site reliability engineering is. Then coming to the final thing on platform engineering. So what is platform engineering and how it is different from DevOps and how it evaluated from DevOps? So right now you are actually talking and asking, creating tickets, reaching out to DevOps teams. That's what your journey right now. But with platform engineering, you are going to build a system where, so you have some a specification file where you are going to give the details about, or like this specification file can be integrated to a very UI friendly user interface. So where you're going to tell, hey, this is my service and I just want to deploy. So you just give the details. You don't need to know anything. So what it will do, it will automatically create the repositories, it will automatically create the pipelines, it will automatically enable that deployment system using whatever the technology is using. For example, containers we are using, Kubernetes we are using, or like how it gets deployed using either Flux CD or Argo CD. So being a developer, you don't have to need to know about anything. So the system is being built in such a way that you just tell, hey, I just want this, I just need a dev environment, and you will get a dev environment with your UI. So you just don't have to wait for anyone to do, or like multiple ticketing systems to get your production to your product deployment. That is what platform engineering is, and that's where the organizations are leading towards these days. Because building a good platform internal to your engineers is very important, because that helps you to deliver things faster. You can just focus on what matters to you. Developers don't need to think about all the necessary deployment tickets or release tickets. No, it just everything is handled with platform. So that's what we are heading towards, and a lot of organizations right now focusing on building their internal platforms to deliver things faster. And coming to the evaluation, so how organizations go through this journey. So they will first evaluate so initially they will just start evaluation on like, so they might be in on-prem or virtual machines. They start evaluating, moving things to containerization through Kubernetes. And then finally they adopt. So they finally start running their workloads on Kubernetes. Start running workloads to build a platform on top of Kubernetes. Why I'm talking about Kubernetes is Kubernetes has gone a tremendous way, because so if you look at the CNCF, they have built more than 300 plus projects just to help you build platforms out of Kubernetes. So if you use Kubernetes, means that gives you a lot of added advantage, because we have a lot of open source projects that helps you to build observability. You don't have to actually implement things end to end, right? You want to do some backup and restores, you have the project, so you have a lot of solutions. So maybe when you go back, you can actually see CNCF landscape. You will understand how many projects, that open source projects that are being built to help you build the platforms. So that's where like people start doing the actual their workloads into the Kubernetes, and finally they will add the platform capabilities. That's what whatever I've said, like building everything end to end. So that comes the end. That's how organizations are moving towards platform engineering. And so if you go through, I mean, a lot of maybe some tutorials or somewhere, a lot of people talk about platform engineering. It means it's internal platform building. But it's not only building internal platforms, it's actually building platforms that are external to the end users as well. That also we call a platform. So I will tell you the difference between internal platform and external platform. So internal platform is something that you are building for your organization based on your developers' needs and based on their feedback and based on their adoption. So you want to build a product for within your organization for your developers to help them uh, give the software delivery the best, so that they can only focus on development. So that is what we call internal platform. So we call IDPs, internal development platforms, right? And so here the customers are your actual engineers. They are the customers, right? And the success of your platform depends on adoption. So how quickly your platform is being adopted by each and every team in your organization. So that's what you call the success as adoption in internal platform. Whereas external platforms, so Netflix is a platform, right? Netflix is a platform, and if, you have so many other platforms. AWS is sometimes, it's a cloud provider, but itself is a platform, gives a lot of other services, right? So we have like Cloudways. Cloudways is a platform. So we have a Kubernetes platform that currently I'm working on as a Cloudways Kubernetes platform. So they give WordPress hosting on Kubernetes platform to the customers. WordPress or Magento. So there are different variety of application hosting that we provide to the customers. So that is another platform example. So my point here to mention you both is because we call both the platforms. It's not only internal development platform. And finally, so when it's an external platform, so how do you measure your success? Based on the revenue. How much profits that you're making, how much you're making your customers happy with your platform features, and how you are actually listening to them and implementing features out of it. So that's what external platform is all about. And now I'll be talking about attributes of platform. So what makes a platform really helpful, right? So first one is you have to see your platform as actual end user product. So this I'm talking in terms of internal platform. So the external platforms you anyway think like a product because it goes to customers. Even the internal platform, you should think as a product. It's not like something just you're building and scaling up, maybe just making up an instance like that. It's not like that. So if you're actually thinking of building a product for your end users. And the experience of users is very important. So for example, if I just build a platform and I just ask them to give them I was talking about specification, right? So usually in a specification file, you will be mentioned about the repo and the feature information and versioning, everything you mentioned. So if you ask the user, hey, you provide the specification and use the platform, maybe the user experience is not that great. So they look for a better UI experience. They might look for a CLI support for your platform. So you have to think about all those different scenarios where you can provide 3 layers: CLI, UI, and how you can directly specify your specification to deploy to production. So that's what comes through user experience. And one of the very good project that really help you with the providing this nice UI experience for your platform is Backstage. That is again another open source product. And finally, documentation and onboarding. That is very important. How you onboard your users to your platform. How you document everything. How you make sure the documentation is very much easy that anyone, so without knowing any knowledge about your platform, a person has to be able to onboard it easily. So that's what the documentation really matters. Because a lot of times we just ignore about documentation. We don't really care about documentation, but the documentation is the key metrics of a platform success. And how you onboard is also important. I will talk more about onboarding and what can go wrong during some platform challenges in the next slides. I will talk about that later. And finally, the major agenda of platform is self-service. So that's what the matter, right? So we're just self-giving everything to them. So they just concentrate on development. And finally, cognitive load of users, they don't have to think too much about whether you're using Kubernetes or whether you're using on-prem, whether you're using Argo CD, whether you're using Prometheus, Grafana, what observability stacks. They don't need to know anything. They just develop, and everything your platform should handle. So that comes with the cognitive load of users. And finally, definitely, if your platform is not secure, so you will end up losing a lot of dollars for sure, and you will end up losing your name and fame of the organization. So security is very, very important. So this is like one of the slide that actually shows whatever the capabilities that a platform can bring. So it includes like infrastructure provisioning of your. See, for example, if a feature has to be shipped, it should provision the infrastructure needed for that platform to be shipped automatically. And also it should be able to build artifacts and go through the policies and finally, storing artifacts and observability, automating tests, everything it should be done. And you can see finally the interfaces which I was talking about, the template, the specification I was talking about, and the APIs and CLIs and documentation and graphical user interfaces, Backstage, whatever that I was talked about. So it should be like, it should give you a full platter of meals together and without knowing the inner details to developer. So that's what the actual platform is. Now, so I was talking more about platforms. So now, do you think what makes a platform good? And so because like now everyone is talking about platform, a lot of organizations starts implementing internal developer platforms. But what makes a platform good and what not? So that is very important. I have seen some example, kind of, I can say a production where I was there seeing a few platforms fail and few platforms succeed. So the reason why I was highlighting here is, there is an example. So one of the organization wants to implement some GitLab. Okay, so they just come up with they just build something, and so what they did was they just so started asking teams to adopt that. So saying that's an CI/CD platform, you can adopt. But the problem here is a lot of teams are using Jenkins. Okay, so if you know Jenkins is like where you can actually automate end-to-end with the pipelines and all that. So converting from that specific project to GitLab needs a lot of effort from developers, because they have to. They might have a lot of projects under each organization, and they have to convert everything. But the wise decision should be maybe they could have think about Cloudbees, maybe to add a better platform to them, because Cloudbees is an extended version of Jenkins where you don't have to work so much about how you convert the code, because it can understand. So it is like enterprise version of Jenkins. So there are the decisions that you make, and how you make people to adopt it also matters. So the other problem I can say, you have built a platform, okay, but you have cut down everything from day one. So means you say there are no DevOps engineers needed, no SREs needed. So we are building platform. Before even building the platform, you have cut down these people, okay. So what happens in the end? Developers' frustration will increase, because if there are no people here until your platform is actually sufficient enough doing things and people get adapted. They ended up creating their own release tickets, and they ended up performing their own releases, and they ended up performing their own deployments. And the feedback that I heard from a lot of people was, we are spending maybe very like 10% of time in developing the product, and 90% of time is getting wasted in doing these things. So that doesn't give a good platform adoption. So these are the mistakes I want to highlight. So if you want to build a platform for your organization, your first point is your customers, right? Who are your customers? Your developers. So you need to talk to them, you need to understand, talk to multiple teams and what they're using. Collectively, you come up with a proposal, and again talk to each of them, like this is what we're thinking, how we can implement, and get a better timelines and implement it, and go through multiple iterations before you make it live. And don't make them, in the process of making developers through platform, don't make them cut down on other things and let them waste their time on doing a lot of extra stuff. So that's the one mistake I've seen organizations doing. So, and the very good platform, how it looks is how you make people to adopt. So the adoption is the success metric for your platform. So you listen to their concerns, you listen to their feedback, come up with a good platform, and slowly migrate things to the platform. And after, once you're done with everything, then cut down on the different process that is already there in the production. So this is what I would like to highlight over here. So I will tell you, this is going to be my last slide, so I'm not going to bore you much. So in life, it's not always the successes that you see. So you always fail, But again, what matters the most is how you stand up out of your failure. So in industry or in the work that you do, you fail a lot of times. You fail to balance things. So if you see any person, successful people, so when you see, you always think, okay, they have at this level, but you don't see how much they have gone through in the journey and how much sacrifices they have done to reach that level, right? So this actually applies to technical knowledge or technical building teams, technical building platforms. So when you start a platform and you fail, don't feel like this got failed. Come up, get another feedback and try to build it out of it. With AI, anything is possible and anyone can be a developer, because so I am more into this DevOps stream, but with AI, I'm actually right now able to build the products and platform features. So the point I would like to highlight here is, a lot of people say AI will kill your jobs, or a lot of people tell you, soon you won't be working, so because AI can do. But right now, the main thought process is how you think and let AI work for you. So that is more important these days, because how you understand the existing platform or existing product, and how you think to make it better, or what customers are needed, and understanding the customer pain points and implementing them, coming up with your ideas and implementing them is the best solution that no AI can replace you these days. So with this, I will end my talk today, and thank you so much for this opportunity. Sorry. question? Sorry. Maybe no questions because I didn't know.
I've got one question.
Sure.
So, any CTO or any IT leader, why should he or she have confidence on CNCF and not go to a COTS product? Why? What's the convincing factor with respect to CNCF?
Yeah. So the thing is, right now, for example, I'll tell you an example of like how a platform people think, because you can see a lot of competitors of each and every platform. So when you're building a platform, you might have 4 to 5 competitors, 10 competitors. So what matters the most is how you understand the customers and how you give cost-effective solution. See, like if you can actually implement, so Kubernetes has a lot of power, and the projects of CNCF that are being outside has a lot of power. You can actually build any solution. You can do anything that will reduce your cloud provider usage also, so that your platform can give with a better cost, and also it can show a better visibility of like how your platform is performing, how your cost of your usage is being calculated using these projects. So I can tell you a lot of examples like how you can use, actually the one of the things that I'm working on right now for a hackathon, like we have this open cost. So that helps you to calculate your cost of resource spend versus cloud provider cost in Kubernetes. So this really helps you to put it out like how much exactly the customer is costing the resources, and can help to better visualize the exact spend across CPU, memory, or load provisions, whatever the resources that they're using it for. So it's not only 1 or 2 projects that will help you, but we have right now more than 300 projects, and a lot of AI compatibility projects are coming up. So that really helps you to build a platform. So that's
Thank you.